Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! First thing we need to do is work out the area of the wall. And so to do that, we're just going to multiply the 44 by the 40. So 44 times 40 is 1,760. And next thing we notice is that each tin covers 10 meters squared. So it actually means we can work out the fact that there are 1,760 meters squared in total for our wall. And if each tin covers 10 meters squared, then we will need 176 tins. That's the amount of tins we need. And each tin costs £5.70, so it'd be 176 times the 5.7, or £5.70, or you could do it as 570 pence and convert it at the end. And that gives us a price of 1,003.2. And so as money, that would be £1,003.20. So we know that the mean is the sum of numbers over the amount. But in this question, we're actually given what the mean is. We're given that that is 29. We're also given the fact that there are 4 cards, so we're given the amount. So what we can do is just get our lines in and solve this. So what we're going to do is just times both sides by 4. So we're going to do 29 times 4, which is 116. And so we know that the sum of the numbers will be 116. So all we need to do is to find the 4th card, is get that 116 and just take away the numbers that we know. And when we do that, we get the answer 26. Now you can easily check this by adding up 37, 26, 27 and 26 again, and then dividing it by 4, and you will get 29. A side elevation is the view you'd get if you were standing at the side of a shape. So I'm standing here, and it's the view I'll get. Well, it would be this trapezium here. And to know which side is the side and which one's the front, well, the front is always going to be labelled. They do normally label the sides as well for you. So we're going to draw this trapezium. So the top bit is 3, then it's 6, then it's 8. So I'm just going to start off with the bottom actually, that might be easier, and draw the 8 across. 1, 2, 3, 4, 5, 6, 7, 8. Then I'm going to do the 6 up. 1, 2, 3, 4, 5, 6. Looks like I left just enough room. Then I'm going to do the 3 across. 1, 2, 3. And then all I need to do is just join up the start and the finish to complete the trapezium. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now this might surprise some people because they will probably think it's a ratio of 4 to 1, but we can show here that it's a ratio of 3 to 1. To find the mean, we need to work out the sum of the numbers, basically what they add up to. And what we then do is divide that by the amount of numbers. Now, what this table is telling us is there are 14 students who got a time between 0 and 4 seconds. Now, it's absolutely impossible to work out what time those students got with the information in this table. So what we need to do is we need to assume they all got, say, 0 seconds or all got 4 seconds. And the fairest value to say that they all got is what we call the midpoint. And to find the midpoint, what you do is you add up the lower bound and the upper bound, so the highest value and the lowest value, add them together and divide by 2. So 0 plus 4 divided by 2, which is just 2. And that gives us a halfway number, which is fair to everyone. So the students roughly probably got 1s, 2s and 3s, and maybe a few 4s maybe. And the average of that is going to be 2, so that's fair for everyone. Same with the 4 and the 8. Halfway between 4 and 8 is 6, and you can add them together, 12 divided by 2, which is 6. Go down finding the midpoints, and we're just going to assume the students all scored the same amount, all got the same time. Then we're going to do our FS column, okay? And so we're assuming that 14 students got a time of 2 seconds. So when you times those together, you get 28. And we're just going to times all of these together. Okay, next we're going to work out the sum of the FS. And to work that out, we just add all of these up together. So we're going to do 28 plus 36 plus 30 plus 126 plus 36. And when you add them all up, you get 256. Now, that will give us the sum of numbers. So we're going to put that into our working out now. And we need to find out how many numbers there are. Well, the frequency column will tell us how many numbers there are. So we're just going to add all of those up together. So we're going to find the sum of the frequency, which is 14 plus 6 plus 3 plus 9 plus 2, which is 34. And when we do 256 divided by 34, we get 7.529 blah blah blah. It says it wants it to 2 decimal places, so we're going to round it to 7.53. To find the median, we need to have all the numbers in a list from smallest to biggest and find the middle num. Now, we can't do that when we're using a table like this, or it's not very practical to. So we need a kind of different strategy, and the way we do it is to use a simple formula to find the position of the median. Now, the median will always be in the n plus 1 divided by 2 position. So we need to find out what n is, and we do that by adding up all the frequencies there. So let's add those together and you get the sum of f. So those add up to 15. So if you do 3 plus 4 plus 2 plus 1 plus 5, you get 15. And so we've got 15 plus 1 divided by 2. 15 plus 1 is 16, divided by 2 is 8. So the position of the median is in the 8th position. Now, to easily find out which group, because it's asking for the class interval, which is just a fancy way of saying a group. So it could be this one, or it could be this one. To easily find out which group the median is in, what we do is a quick running total. So what I'm going to do is add up the frequencies as I go along. So we've got 3 there. 3 plus 4 is 7, plus 2 is 9, plus 1 is 10, plus 5 is 15. And then what I do is just convert those into 3rd, 7th, 9th, 10th, and 15th. So what those numbers are the last time that a number is in that group. So we've got 3 numbers that are in the group 10 to 25, and the 3rd one is the last number in that group. The 4th one, therefore, will be in the 25 to 40 group. So we're looking for the 8th one. Well, the 7th one is the last one in this group. So the 8th one will be in this group here, as well as the 9th. Then the 10th one will be in the next group. So when it asks for a class interval, all we need to do is copy down exactly what the group is. So it's 40, to 55, and don't ever write down 40 to 55 or anything like that. Always copy it exactly from the table. So let's look through this question to see what information we're given and what information we're looking for. So we're given the acceleration is 13 meters per second squared. We're also given the distance is 19, and we're also given the end velocity, which is v, is 34. And we're looking for the initial velocity. So which of these formulae include A, S, V, and U? That's got a T in it, that's got a T in it, so it's going to be this one here. So let's write that out. V squared equals U squared plus 2AS. So that would be 34 squared equals U squared, because that's the one we're looking for, plus 2 times 13 times 19. Okay, so let's just work these parts out. And so we've got 2 times 13 times 19, which is what, 494. And it turns into a solving part, so we're just going to solve this. So the first thing I'm going to do is subtract 494 from both sides. And so we're left with 662 equals U squared. Then we're just going to square root both sides. And so square root of that is going to be 25.729 blah blah blah. And it says it wants it to 2 decimal places, so it's going to be 25.73. So factorise means to put it into a bracket. And it looks like it's a quadratic here, but it's actually just a linear factorising because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10, and that will leave 2 and 3. So that's the numbers done. Next, I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally, I'm going to look at the u. And there's just a u on both of them I can factorise out. And actually, that just leaves nothing on the inside of the bracket. Now, always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30, times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. This question seems a lot harder than it is. What I'm going to do is I'm going to start by rewriting the prime factors, but without the squared. So 2 times 3 times 3 times 5 times 5. I'm going to do the same with the other list as well. So 2 times 2 times 3 times 11. Now I'm going to put these into a Venn diagram. And so I'm just going to draw out a Venn diagram and get my 2 circles, because we're going to have the 450 and the 132. So 450 is on the left hand side and 132 is on the right hand side. And we're going to start just filling out the Venn diagram. So they both have a 2 in them and they both have a 3, but 450 has a 3, a 5 and a 5. And 132 has that 2 and the 11. Now to find the lowest common multiple, what you do is you just multiply all these numbers together, and that will give you the lowest common multiple. So what we're going to do is we're going to do 3 times 5 times 5, which are the numbers on the left, times 2 times 3, which are the numbers in the middle, times 2 times 11. And when we do that, we get 9,900, and that's it. So our answer is 9,900. To answer this question, we need to know what an equation, expression, formula, and identity is. So the formula is basically an equation but for real world things. So area equals pi r squared. It's where the letters actually mean something. Expression is just algebra without the equal sign. So 5x plus 3 would be an expression. An equation has an equals and it can be solved. So you can find out what x is or find out what a is. And an identity is true for all values of that letter. So an example would be x times x equals x squared. That's an identity because that's true for all values of x. So looking here on the right hand side, we've got 3x plus 2x. But if we imagine x is 10, so 3x would be 30 plus 2x would be 20, 30 plus 20, well that will equal 5x, 5 times 10. And actually this is true for all values of x. And the reason it's true for all values of x is we know that 3x plus 2x, this right hand side here, equals 5x. They're the same thing. Now normally with an identity, it's shown with 3 lines. Now in the exam, this type of question, it won't be shown with 3 lines because that kind of gives it away that it's an identity. But this question is definitely an identity. And you can't solve it because it's true for all values of x. So yes, x could be 10, x could be a million, x could be a third, x could be anything. When proving two triangles are congruent, and congruent means exactly the same, we're going to have one of 4 answers. Either side angle side is the same, angle angle side, or angle side angle. Side 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 are the same, or they have the same right angle, hypotenuse, and side. This question doesn't have a right angle, so we can cross that out. It has 2 lengths, so 2 sides, but not 3, so we can cross that one out. It only has 1 angle, so we can cross this one out. So we're looking to see whether it has the same side, then angle, then side. So here we've got 13 as a side, then 139 as an angle, then 6 as a side. 13 as a side, 139 as an angle, and then 6 as a side. So they have the side, angle, side. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44 v to the power 4 w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11 v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11 v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4 w to the power 5, it's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4 w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power 4 w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power 4s together, and remember with indices, if you times 2 powers of the same base, and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power 5s together, so that makes 10. So it's 121 v to the power of 8, w to the power of 10. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power 4 times 13 times x to the power 4 times y to the power 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it, so I'm not changing anything. I'm going to put the x's together. And I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power of 4. Now we know when we multiply two powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. So it'll be x to the power of 16. And then y to the power of 4 times y to the power of 4, we just add them together, so it's y to the power of 8. So we're asked to find the bearing of Freetown from Gamley. So that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got a 90 degrees here, we've got a hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, so we can cross that out. And we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA. And so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in. And we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah, blah, blah. Okay, so we know that the whole of the way around up until this point is 270 because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah, blah, blah. And that gives us 243.434, blah, blah, blah. It says it wants it to the nearest whole number, so that's going to be 243. To find the perimeter of this sector, we've got to first of all find out the length of the arc, which will be this part here. And the formula for arc length is, first of all, we find out the fraction of the circle we have. So we put the angle over 360, and that will tell us the fraction of the circle that the sector is. And then all we do is we times that by the circumference, which is pi d. And so that's going to be 49 over 360 times pi times, and the diameter would be twice the radius. The radius is 7, so it would be times 14. When we do all of that, we get 5.986, blah, blah, blah. But that is not the perimeter yet. Perimeter needs to include, get the right ones, needs to include these parts here. So the perimeter will be the 5.986 plus a radius plus another radius. And when we do that, we get 19.986, blah, blah, blah. And we want to round it to two decimal places, so that will be 19.99 centimetres. First thing we need to do is work out the volume of this prism, and it's a trapezium-based prism. So the volume will be the area of the cross-section, or area of the trapezium, times the length, how 3D the prism is. So trapezium is half a plus b h, and then times the length. Now A and B are the two parallel sides, which will be this one and this one. And then the H is the perpendicular line that hits both of them at 90 degrees. So what perpendicular means, between the bases. So this will be the 25 meters here. So it's going to be half, and then we're going to add 1 and 5, times that by 25. The length is how 3D it is, so it would be that 10 there. So we're going to times that by 10. and that will give us 750. So it's 750 meters cubed. Now, there is a little formula we can make for the rate. So the rate of anything for this will be the volume gained over time. Now, with this question though, we're interested in the time it will take. It says how long will it take. So we're actually looking at the time. So it will be time equals the volume, which is 750, over the rate, which is 15. So 750 divided by 15 is 50. So it will take 50, and let's have a look. It says per minute. So it would be 50 minutes. It's sometimes easier in these questions to view these triangles as two separate triangles rather than one triangle. So we're kind of just going to split this triangle off and just move it to the side so we can see what's going on. I'm going to do the same with the smaller triangle and kind of move that to the side. So we can see we've got two triangles here. We've got a big triangle and small triangle. And we can label the sides of them as 18. Now this long length would be 20 plus x, 20 centimeters plus x. Then we've got 6 here and we've got x here. Now the two triangles are similar because the sides here we assume are, well, we know they are parallel because they are right angles, and they share an angle here, which we can just label as A, and so they are definitely similar, which means that one is an enlargement of the other. So we need the scale factor first. Now if you look at the 6 and the 18, they are what we call corresponding sides. So we need to work out the scale factor by finding out what I multiply the 6 by to get to the 18. Well, that's obviously going to be 3. So we now know that we can times the x by 3 to get to the 20 plus x. So we can write that down. 3x, I'm timesing the x by 3, and that will give me 20 plus x. And so I can solve this now. Subtract x both sides. Always subtract the smaller amount, so 2x equals 20. And then divide both sides by 2. And so we've got x equals 10. So we know that x equals 10, it says find the length x, and so that will be 10. First thing we need to do is find out what 10% of the 109 is. So we're just going to multiply by 0.1. And that gives us 10.9. So what we're going to do is we're going to add and subtract this from 109. So we're going to do 109 take away 10.9, which gives us 98.1. And then we're going to do 109 plus 10.9, which will give us 119.9. So our error interval is between 98.1, and it says to use t, and 119.9. So we've got Billy and James and Sam, and James collects 20% more sand than Billy. So we've got James and he's plus 20%. And Sam collects 60% more sand than James, 60%. And you'd think you'd just add the two. Obviously, it's not going to be that easy for 3 marks. So the answer is not 80. What we've got to do is find the multipliers for each of these. And so what we're going to do is we're going to start off with 100%, add the 20%, and that would be 120%. Then we're going to get the 120, divide it by 100, and that gives us the multiplier, which would be 1.2. So the multiplier from Billy to James is 1.2. So however much Billy has, if we times it by 1.2, we get James's amount. Do the same for James to Sam. So start off with 100%, add 60 is 160%. Then just make that a decimal, so 160 divided by 100, 1.6. So if we multiply anything by 1.6, it will increase it by 60%. Now it says, by what percentage is the amount of sand collected by Sam greater than the amount of Billy? So what we're going to do is we're going to start off with Billy being 100%, okay? We're going to times it by the 1.2, and then times it by the 1.6, and find out what the final percentage is. So when we do that, we get 192. So we started off with Billy's 100, we just made that up, but it just makes the maths nicer to use. And we ended up with Sam having 192. Well, what is 192 as a percentage increase of 100? Well, the reason we picked 100 is we can clearly see that it's gone up by 92%. So our answer is 92%. So we're going to start off just by copying down the same equation. And we're asked to make B the subject. So we're going to put our solving lines in. So the first thing we need to do is get rid of this 10 here. So we're going to divide both sides by 10. And that will mean we have a fraction here, a over 10. And we've got the square root b over 3. Now we need to get rid of that square root. So what I'm going to do now is square both sides. Now to square a fraction, we square the top of the fraction and we square the bottom of the fraction. 10 squared is 100. And that will equal b over 3. And we want to get rid of this next, so we want to times both sides by 3. To get rid of a divide by 3, we times both sides by 3. Now with a fraction, when you times it by something, you actually just times the numerator, the top, by that. So it's going to be 3a squared over 100 equals b. So b is 3a squared over 100. Okay, so first thing I'm going to do is just a quick sketch of this diagram. So we're told the lengths are 8 and 6, and the angle between the lengths is 64 degrees. And we've kind of got a missing length down here which we need to find. So we need to find that one. Okay, so let's label them. Now we're going to be using the cosine formula. So cosine formula involves angle A. So we're going to label the angle A. And the one opposite, the one we label as A, is going to be little a. And then little b and little c, it doesn't matter. Right? It doesn't matter which way around you do them. So we're going to write down the cosine formula. So it's a squared equals b squared plus c squared minus 2bc cos a. And so that would be x squared equals, and that will be 8 squared plus 6 squared minus 2 times 8 times 6 times cos 64. And that will be x squared equals 57.916 blah blah blah. And we just need to solve this, and we can solve it by just square rooting both sides. So it would be x equals 7.61000 blah blah blah. Okay, we're asked for the perimeter, and so we need to do 8 plus 6 plus that 7.610 blah blah blah. I've still got on my calculator, and that equals 21.610 blah blah blah. It says it wants its 2 decimal places, so it will be 21.61. I'm going to start by identifying the equations of each line. So here we've got y equals 2, because the y coordinate is always 2 on this line. This one here we've got x equals minus 3, because the x coordinate is always minus 3. And this next one is a bit more difficult, but it's perfectly diagonal, so it's going to be a y equals x line. But if you look, it crosses the y-axis at minus 1, so it's going to be y equals x minus 1. Okay, these are not inequalities though, so we need to work out what the inequalities are. So we're looking at the region which is here, and we can pick a point in the region, I normally try and pick a nice easy one, so let's pick 0, 4. So 0, 4 is in our region. So 0, 4, let's compare that to our y equals 2. Well, what is that compared to 2? Well, it's actually greater than 2. So it's y is greater than 2. We have a look, the fact that our line is dashed, it's not going to be equal to 2 because it's saying it's not on that line. Okay, this next one, let's have a look at this. Well, is it greater? Is that 0 greater than minus 3? Well, yes, it is. So it's going to be x is greater than minus 3. Again, the line is dashed, so it can't be on the line. Now, this last one's a bit more difficult because it's got x and y in it. So we feed in the values. So for our coordinate that we've picked, x is 0 and y is 4. So 4, and I'm just going to put, I don't know, not equal to, but or I'm just going to leave that blank, leave that as a box. And 0 minus 1. So all I've done is fed in the coordinate values into this equation. And I've got rid of the equals because what we need to do is work out what inequality it's going to be. 0 take away 1 is minus 0. So what is 4 compared to minus 1? Well, 4 is definitely greater than minus 1. So it's going to be y is greater than x minus 1. But if you look, this line is solid. It's a solid line. It's not a dashed line. Therefore, we're going to put a little line underneath it because it can equal it as well. So here we're going to solve a quadratic using a calculator, using the quadratic formula. And the reason we know that is it asks us to do it to 2 decimal places, so chances are it's not going to factorise. So we're going to find out what a, b and c are. And a is the number before the x squared, the coefficient of the x squared, which would be 5. B is the coefficient of the x, which would be minus 6. And then c is the number left over at the end. So we're going to write the quadratic formula, but with our values in it. So we have minus b. Now I always put the values I substitute in brackets, and the reason is that if they're negative, you can make mistakes, especially here. When it's b squared, if you don't put it into brackets, it won't give you the right answer because it will square the 6 and then put a minus before it. Minus 4 times a times c. And if you always put them in brackets, you don't even have to think about it. It'll always be right. And then over 2 times a. Okay, we're going to put that into our calculator with a plus there first. And it gives us 2.320 blah blah blah. And we're going to do the same thing again, but we're going to use our calculator to go back to the plus there, and we're going to change it to a minus, and then we're going to press equals. And that gives us minus 1.120 blah blah blah. So it's 2 decimal places, it's going to be 2.32 and minus 1.12. There are 2 shapes we're interested in this question. There's this sector here, which we can work out the area of. And there's this triangle here, which we can work out the area of. What we do is we work out the area of the sector and then we subtract the area of the triangle. So I'm going to start off by working out the area of sector. And we know that that is the angle that we have of the circle times by the area of the full circle. So the angle we have is 39 over 360. And then we've got pi times 10 squared. Type that into your calculator and you get 34.033 blah blah blah. Next we're going to find out the area of the triangle. And we use the, well, if you have a look at the triangle, we've got 10 centimeters here because that is also a radius of the circle. So we've got 2 lengths and we've got an angle, so we can use the half AB sine C formula. So we've got half AB sine C. And so A and B are going to be our lengths, and C is going to be this angle here. So we've got a half times 10 times 10 times sine the angle, which is 39. Then when you work that out, you get 31.466, blah, blah, blah. Okay, so to work out the area of the segment, all we're doing is the area of the sector, like the full area, take away the bit we don't want, which is the triangle, and that will leave us the area of the segment. So we're going to do the 34.033 blah blah blah, take away 31.466 blah blah blah. And what I've done is I've saved them on my calculator so I can do it precisely. And when you subtract them, you get 2.567 blah blah blah. Once it's 2 decimal places, so we're just going to round that to 2.57. So this is a completing the square question, and I'm just going to write the question again, just so I can explain it a little bit better. So the main thing we're looking at for this question are the first two terms, the x squared term and the x term. And how you complete the square is you put a set of brackets down, you put an x first, and then you put half of the coefficient of the x term. So the x term, the coefficient is plus 10, so half of that would be plus 5. Then you put a squared there. Now I'm going to come back to that in a second, and I'm going to go off on a bit of a tangent, and we're going to square x plus 5 over here. So x plus 5 squared is the same as x plus 5, x plus 5. And so x times x is x squared, then that would be 10x, and that would be 25. So you can see the first two terms are exactly the same as the question, but we have this plus 25 here we need to do something about. So the next thing we do is remove that 25. So we take away that 25 that bracket creates. Then we add the 11, which was just part of the question. So the next line, the last thing we need to do is just do minus 25 plus 11, which is going to be minus 14. And then the P would be 5, and the Q would be minus 14. So we know that the cuboids are similar, so there's going to be scale factors. And we're given the two surface areas, so we're going to first of all start there. And we know that there's going to be a scale factor between them. So what do we times the 9 by to get to the 272.25? So we're going to do 272.25, the big one divided by the small one, to find out what the area scale factor is. And when we do that, we get 30.25. So the area scale factor is 30.25. Now this question is all about volume, but we're going to work a little bit backwards, and we'll find out that the area scale factor is the linear scale factor squared. So we're going to work out what the linear scale factor is. So to find the linear scale factor, we're just going to square root the 30.25, the area scale factor. And when we do that, we get the answer of 9. So square root, 5.5 even. Didn't sound right. Okay, so when we square root that, we get 5.5. Now, we know that the volume scale factor is equal to the linear scale factor cubed, because there's 3 dimensions. So we know it's going to equal 5.5 cubed. And so the volume scale factor is going to be 166.375. Okay, so that's the volume scale factor. Now we're given the larger cuboid has a volume of 8984.25, and we're looking for the volume of the smaller one. So with scale factors, to get from the smaller to the bigger, we times it. To go the other way, we just divide. So we're going to divide this by 166.375. And then when we do 8,984.25 divided by the volume scale factor, 166.3275, we get the answer of 54. Here we've got a half on the outside, so our function's been multiplied by half, and all that's going to do is it's going to halve each of the y coordinates. So we've got a y coordinate here, and half of 6 will be 3. The 3 we've got here will be 1.5. The bottom of the curve here will be at 1, and you just go through and just halve all of the points on the graph. And when you do that, you should be able to draw in the graph, and it should look something like this. We'll try our best to draw it. And we're not looking for it to be absolutely perfect, but looking at that, you can clearly see that all of the y coordinates have been halved. So we have the original y equals fx shown in the graph, and it says it has a minimum at 1, minus 1, so it's this one, it's the black line here. And we're looking to see the new function, the red function, but we notice that actually it looks very similar. It's a U shape for what we can see. It might not be a quadratic, but it looks like a quadratic. And we notice that the point at the bottom has shifted left 1, 2, 3 spaces. Now it's tempting to think that the new function will be f brackets x minus 3. That would be what would be tempting to do, but when you're looking at transforming graphs along the x-axis, it's actually the opposite of what you think. So the actual answer is f brackets x plus 3. So this one would be wrong. So at the point on the graph where x is 12, it's this point here, and what you need is a ruler, and what you're going to do is rest it on so it becomes the tangent of that point. So I'm going to try my best to do it here. I'm just going to draw it out, and this is going to be my ruler, and I'm just going to move this into place. So we want that to be a tangent at x equals 12, which is about here. And then what you do is work out what the gradient of that line is. So I'm just going to draw a line across and up. And we know that gradient is the change in y over change in x. The change in y is 2, and the change in x is 1. 2 divided by 1 is just 2. So the gradient at x equals 12 is 2. Now notice it says x equals 12. It's a curve, so the gradient's constantly changing, but an estimate of the gradient at that point is roughly 2. And you just need to make sure you rest the ruler down, and then until you're happy with it, draw the line like I've done with the blue line, and then just work out the gradient of that. And if you just show all your workings, show the examiner how you've come up with the value, even if your gradient's slightly off, you might still even be able to get full marks on some of the papers, if not 1 out of the 2 marks maybe. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.